Let's go through LeetCode 1354. Construct target array with multiple sums. For this question, give us an interarray target, and it has length n. Initially, we have an array with length n, all of the number to be 1. So we can do the following procedure. So we'll say we can choose, that is, choose any number to be the sum of all of the elements, trying to see whether we are able to achieve target. So for example, 935, right? 935, we know we can have 111 and put the second number as the sum of the sum, that is 3, right? And then put this kind of index 2 to be the sum 1 plus 3 plus 1, this is 5. Then put 9, right? So it is achievable, return true. And second example, 111, right? So we'll see the next step, it will be 1114 instead of 111. We'll never reach 111, right? And the third, 85, right? So we know 1, we have two choices, that is can be any 1, 2, or 2, 1, right? And for the 1, 2 case, we can have, for example, 3, 2, or 1, 3, right? So the same thing with 3, 1, 2, 3, right? And 3, 2, we have choice as, for example, 5, 2, and 5, 3, right? And for the 5, 3, it has a choice as 8, 5, right? Or 5, 8, right? So 5, 3, right? 8, 3. As long as we are able to get a 3, 5, 3, right? We should be able to get 3, 5 as well. So in this branch, right? So that is 8, 5, 8, 3. Right? So 8, 5 is achievable. So you return true. Intuitively, what we're thinking about is that we do the search, right? Like a binary search, like a BFS, right? We start from 1111, trying to see whether we can search the target. But doing like this, it will be a lot of search branches. And for this question, is going to go to TLE and auto use auto memory. So the good thing is that it already give us the target, right? So we know for every target, it can only have one parent. So what for example, 935, we know the last step will always coming from adding to biggest number, because at the sum will always be the greatest, right? So what I was thinking about is that we can have this number minus the rest, but minus 8. So that is 1, 3, 5, right? And so we know its parent can be 1, 3, 5. So same way for 1, 3, 5, what's its parent? It can only be 1, 3, 5 minus 4. That is 1, right? And also the parent can only be 1, 1, 1. So what we do now is, instead of search from 111 to the target, can we just search from target to the parents, right? So how can we search from the target to the parents? So every time the largest number, we minus the rest. That is one step, right? Here is another thing we need to consider. Uh, for example, we have a number 801 and the number 3 and the 5, right? We know its parent can be minus 8 is 7, 9, 3, right? And that's 3, 5. And then its parent can be 8, 7, 8, 5, 9, 5. Then its parent can be 7, 7, 7, right? So we'll find when this number is very greater than the rest of the sum, it will only when we go through the parent's test, it's only um operate on this number. So can we operate this number efficient? Instead, we can't, right? Because in the end, what we did is that we have 8, 100 minus 3 plus 5, that is 8, multiplied by 100, right? So we can minus this 800 in one step, right? So become 135, right? So because it's always going through this kind of path. So, if this is, for example, we call the largest number V, right? And the rest will be R. So we need to find a way to calculate this K, right? So, what we do is that for this kind of V, we divide by R. Get how many times, right? And the things that there are some cases, for example, 101, right? Well, it's not able to iteration false, but doing like this way, it will return true. So what we do is that instead of have, for example, this is k, right? V minus k is multiplied by r. Instead, to have v minus this kind of number, right? We have v minus 1 divided by r, so that when k multiplied by r, it will never exceed v, right? So this one, not because of this one, we get this as 0. Because we still need to, if this one gets 0, we should keep the v minus k minus multiplied by a positive number, so that we can choose the rest. For example, after we get this as 1, right? And then we can choose 3 and 5. The rest will be 5 to do the similar simulations. So let's write code for this. So we know there is counter cases, right? If this kind of let's say uh target, if this target dot length equals 1, which return target 0 equals 1, right? Because we cannot use the sum and the rest for the single element array. And also for single element, only this one is true. Then we are going to have priority queue. We have called max heap for new priority queue. We have collections reverse order. So what we do is that we need to include those kind of numbers from the target, right? Every time we get the largest one. So in the meanwhile, we can get a sum out, right? For every num in target, we're going to have max heap offer this num, and also we have sum plus equal to no. And we'll say why this kind of heap is not empty. Then we get the largest number, right? So we know the rest will be the the rest will be, for example, the rest will be the sum minus this kind of number, right? As we know, this kind of indicate how many times will be um like this, right? Int v minus one divided by r, right? This will be the times. And for these times, it is possible it is zero, right? If it is zero, what do we do? Is that we set this one as one from trying to see whether um the next time we minus this kind of rest will be um negative, right? So that is, for example, we have three, two, two, right? That means if this is not the many times, so divide by this one will be zero. Cannot. So what we do is that we have k to be at least one, so we can use a max one, right? For this kind of k. Then we'll have v minus equals k multiplied by r. And the sum should also minus equals k multiplied by r. Right? So let's say if this kind of v is smaller than one, right? Just the case, the largest one, minus the rest is less than one, right? We return false. Otherwise, we have a max if offer v, right? So that means that we can put a conclusion here. If v equals one, that means the largest number we get from the max heap is already one, right? The rest will always be one, right? We just return true. In the end, actually, we can also return true, but this one we terminate early. Um, the Python code, it's a real Python code. So we'll say if length target equals one, we're going to return target zero equals one, right? Then what we do is that the max heap equals we'll use max heap, so it should be negative now for num in target, and equal to the heap file max heap and total t sum equals sum target. So while we can say while true and max value equals we'll get this heap q the heap top max heap, right? The remaining value will be total sum minus v, right? So I say if the remaining value is if the max value v is already equals one, that means everything else is one, then just return true. So we have k equals max um, max value, so that v minus one, right? And we divide by remaining, right? And uh, and at least one. So we're going to have v minus equals k multiplied by r, and we are going to have t sum also minus equal to k multiplied by r, right? So I say if this kind of v is smaller than one, return false, and we are going to have push this number into the cube, right? Heap cube, to heap push max heap uh, minus v, right? And for Python, we don't need to have a return outside because uh, this kind of case it will always have the return, right? Max heap, max heap is never defined. Do you mean? Did I?